All right, so let's go ahead and take a look at the difference between some of the series resistive circuit formulas and the parallel resistive circuit formulas. So previously, yesterday, you guys were working on series resistive circuits, and today we're going to be using these formulas down here. Now, there's a couple similarities, but if you get these mixed up, you're going to definitely get the wrong answer, especially as we move on to the combination circuits. So one of the biggest differences I can point you to is you're going to see before we were adding up the voltage drops to find the total voltage here, well as now it's kind of like the current was in the last ones in the fact that it's the same across every single resistor. And now the current is additive. So we kind of flip-flop these two from yesterday for parallel circuits. And then on the resistance values, there's a couple different formulas you can use right here. Now, I'm going to say not to worry too much about this one for now because the other one you can use in pretty much every single resistance circuit that we work on. But with the other resistive formulas, it kind of depends. Like there's a maximum amount of resistors for one, and then the other one, all the resistance values have to be the same. But if we use this one right here, it pretty much works every time. So we're going to go ahead and just use that one for practice purposes for now. So for this one of the key factors for putting it in correctly is making sure you know how to use your calculator properly. So we'll pay attention. I'll pull up a scientific calculator here when we get to that part on the equation the circuit we're going to solve, and then we'll show you how to do that, make sure everyone's doing it right. So just keep in mind some of the differences and don't mix up which formulas to use when you're using series or parallel circuits. So if we go ahead and pull up a circuit over here, we've got 125 volt total supplying 3 parallel resistors, a 20, 100, and a 50 ohm resistor. I'll fix that right there. So we've got our little chart here for voltage, current, and resistance. And we'll go ahead and label these for our chart so we don't mix up the values. So we got R1, R2, and R3. Now if we go back and look at our formula, we're going to be going ahead and using this one right here because we don't have enough values to solve any of these yet. So we're going to look to get the total resistance. So let's go ahead and fill in the values we have right now first. So we got 125 volts here. And then for R1, for the resistance value, we got 20 ohms. R2, we got 100 ohms. And R3, we have 50. So we don't have two values in any one of these categories yet, so we can't apply Ohm's law to it. But we can find out the total based on that formula we had for the parallel circuits. So just to write that down over here, RT equals 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. So let's go ahead and fill in those values here. So 1 over 20 plus 1 over 100 plus 1 over 50. Now what's that going to look like putting it into your calculator? We'll go ahead and take a look at that right now. So get your calculators out, and then I'll pull up a scientific calculator over here as well. So to fill in those values on your calculator and let it do all the work, we're going to be doing 1 divided by, now this is the most important part not to forget, you want to put a parenthesis here so that it knows the order of operations you want to do. So you want to divide 1 by the total of all of the rest of those fractions down there. So for that parenthesis right there, it's going to tell it to add all those together before you divide by 1. So we got 1 divided by parenthesis. Now we can just do 1 divided by 20 plus 1 divided by 100 plus 1 divided by 50. And we get 12.5 ohms right there. So that's your RT, your resistance total for that entire circuit. That's how you plug it into the calculator, and we got our little equation written out there. So let's go back over here and fill in the values. So 12.5 ohms was the total for that value. So we got that done. RT equals 12.5. Now we're able to solve using Ohm's law. So we got the voltage and we got the resistance. So we know how to put that into Ohm's law, right? We're going to go ahead and take the voltage and divide the resistance, and that's going to give us the current. So punch in 125 divided by 12.5, and that's going to give us 10 amps. So what does that really do for us? Well, what that does is, if we remember what the current in a parallel circuit is, if you look at your formula, it adds up, right? What about the voltage? So the voltage is the same across every resistor. So the easiest thing for us to do with that is we can just carry that over. So every single resistor sees the same voltage. So we don't even have to do any math for that one. There's a couple different orders you can go in here, but we found the total resistance first. We got the total current. Now we got two values in every category for the individual resistors. So we're just going to do the same thing with those. So we got 125 divided by 20, which is going to give you 6.25. 125 divided by 100 gives you 1.25. And then 125 divided by 50, 2.5. Now, when we were just looking at the formulas, you remember if you add up all of the individual current values, it should give you the total. So to check our work, let's go ahead and put in 6.25 plus 1.25 plus 2.5. And that should give you 10 amps, your total. So if you're able to solve backwards and check that, you can know with confidence that you got the right answer for those totals as well. So we'll do a couple other ones. This is probably as easy as the parallels are going to get. It's going to get a little bit more difficult from here, and we'll show you what to do if you have other values besides voltage totals and resistance values. And then we'll use Ohm's law pretty much to break it down and solve it on a resistor by resistor basis.